Okay, so chapter 9, this is the first part of the trigonometry stuff. A lot of it is GCSE, so it follows on from cosine rule, the sine rule, area of a triangle, a lot of which you should remember from GCSE. I'll just quickly go through them just in case. So this is one way of writing the cosine rule, the other way is to have cos A as the subject. I like this way because it just starts off like a squared equals b squared plus c squared. It's like Pythagoras' theorem, but take away 2bc cos A. B and C are the lines, the lengths of the lines next to the angle, this angle A, and A is the length of the line opposite angle A. You use it when the question in some way mentions three sides in an angle. Obviously, there's two ways of using it, one to work out a side and the other to work out an angle. I think it's more obvious to use it when you're trying to work out an angle and you've got all three sides, because you can't even start to attempt this one. But it's not always totally obvious, but if you've got some kind of geometric problem and there's not a right angle involved, that should be on your radar for like triangles where you don't have a right angle. Same thing with this, you can flip this upside down as well, so sine A over A or sine B over B, depending on which way you're using it. But you use that when you've got two sides and two angles in a question. Again, you could be working out a side, you could be working out an angle, but if you've got, say, two sides and one angle and you want another angle, or you've got two angles on one side and you want another side, the sine rule. We've got here area of a triangle where it's not right angled. Half AB sine C works if it's right angled as well. Sine of 90 is 1, so it's just half AB again. What I see a lot is people jumping to use this when actually there's an easier method, so just using a normal triangle equation. If you've got a triangle where either one of the lines is vertical or horizontal, you can normally just use half base times height using the coordinates. So look at that in detail before you start trying to work out all the lengths and using Pythagoras to work out lengths and then using this and trig. Sometimes you can just use half base times height. Down here, hopefully you recognise them, it's the sine graph, cosine graph and tan graph. The most important thing to notice about them is all the solving stuff with the extra, that's chapter 10. But these go between 1 and -1, so sine and cosine go between 1 and -1. Tan has asymptotes at 90 degrees and 270 degrees. But there's no maximum or minimum point, so you can always solve tan x equals a constant. So you could solve tan x equals 2, but you can't solve cos x equals 2 or sine x equals 2, because they just don't have solutions outside of that 1 to -1 range. Onto the intermediate stuff. It's all the same cosine rule and stuff, but combined with other things. So once they start adding different types together, once the marks go above, say, 2 or 3 marks, you're going to have to do more than one thing together. So, for example, if I've got these points, I might have to, if I wanted to work out an angle, for example, I want to work out angle CAB, this one, what I'd have to do is work out the lengths first by using Pythagoras. So that brings all the way back to chapter 5 where you're working out lengths on a graph, but doing that and then as well as that doing the cosine rule. That's the kind of thing you're looking for when you've got say a multiple step process with like more than 2 or 3 marks. So here you'd work out the length of the side, 7 squared plus 3 squared square rooted. Here, what's that, 3 squared plus 7 squared square rooted. So that's actually a isosceles triangle that I've drawn, because that's 7 squared plus 3 squared, and then that's 3 squared plus 7 squared, which is going to give you the same thing, so that's an isosceles triangle. It might even ask you to prove that it's an isosceles triangle, in which case that's what you do. But yeah, you work out the lengths of all 3 sides, and then use the cosine rule to work out an angle. So once you've got a squared, b squared and c squared, I would also point out that it's probably useful to keep them as square root. Don't try and simplify the square root, because here, if you watch, it's 7 plus 7 squared plus 9 squared is 58. That is root 58, that's root 58. If you keep it as that, then you don't need to do much there when you do squaring. It might help you out. Also with SOHCAHTOA, there's a few things. You could use SOHCAHTOA on different parts of this, depending on what the question was. There's so many right angled triangles there, even though that triangle isn't one. You could have a right angled triangle here and work out, say, that angle, if that's useful. So you have a lot of like different arrows in your quiver. SOHCAHTOA is one of those. So adjacent for one of the angles, and the sine of the other angle are going to be equal to each other. They're both over the hypotenuse, and yeah, so cos of 53 and sine of 37, because they add up to 90, they're the same. And then the last thing is just move it. Is now at 7 instead of 5. The trough